Let's start with the session 2, disaster risk assessment process. The risk assessment, as I said earlier, is a function of hazard, exposure, and vulnerability, where hazard is the probability and severity of disaster events. Exposure and vulnerability goes with the consequences of the disaster events. So this is the step 1 for hazard assessment. So in risk assessment, the first step is that we have to identify the hazard. The basic step in risk assessment, it helps to identify the threats and understand their nature and behavior. So hazard assessment comprises of two key elements, hazard characterization and frequency analysis. In the hazard characterization, it's an in-depth study of monitoring hazard to determine their potential, origin, geographical extent, impact characteristics, historical nature, triggering factors, etc. Where in the frequency analysis, we can do quantitative or qualitative estimation of probability of occurrence and related to the return period. This is one of the example of hazard map with the return period of 50 years and showing that what would be probable flood depth in one of the areas. The step 2 is consequence analysis, exposure and vulnerability analysis. This step determines the elements at risk from a potential hazard and analyze their vulnerability. This helps us to understand element at risk, what are exposed to hazard, baseline data required. This is exposure, and identify why these can be damaged, destroyed, what make the exposed elements susceptible, and the root causes, which is called vulnerability. Element at risk, the exposure obtained by survey or by using records such as census data. If a measure of economic risk is required, then a value must be established for the elements. The major issue faced in this step is the lack of availability of data and the issue of data confidentiality. So this is one of the example of exposure map where we put up this building footprint in an area. Vulnerability assessment helps to identify the root causes of elements at risk and the reason why these can be damaged. Some specific hazard-related vulnerabilities would include vulnerable groups, social vulnerability, unsafe infrastructure, physical vulnerability, non-diversified economy, economical vulnerability, and deforestation, like environmental vulnerability. So these are two different buildings or element at risk, and which one is more vulnerable. So this is all depending on if we go with the physical vulnerability for flood risk, of course, as against to seismic risk, so the issue would be different. So we need to look at like what are the hazard we are looking at against which element at risk is vulnerable to what degree. Number 3 step is the risk estimation. So this is just a simplistic equation we put up. Actually, the major equation is a function of hazard, vulnerability, and exposure. Risk estimation involves the assimilation of the results of hazard assessment and consequences analysis to derive an overall measure of risk. Risk maps are maps that contain quantitative information on the risk and the impacts on people, property, environment, etc. The estimated risk can be derived from either quantitative or qualitative calculations and may be expressed among other ways in terms of number of fatalities per year or the estimated value of damaged properties per year. So on one of the example we can show, this is a flood map, hazard map with the extent of the flood, if you can see that with the color coding. Then we overlay the building footprint over there, so it's a element at risk which are falling under the hazard zone. And then once we use the damage curve, then we come up with like based on the typology of the building and setting of those buildings, how much of buildings are falling under the damage percentage, more than 80%, 50 to 80%, 20 to 50%, or none. So if you see like most of all the buildings that are falling on the risk zone are within that area where hazard is prevalent, which is actually more rational. So understanding risk assessment methodology can be varied from historical event hazard characteristics, hazard statistics, meteorological, geological, hydrological data, GIS, satellite image, scientific data, field survey, community appraisal tools, focus group discussion, etc. It requires partnerships between many stakeholders, including scientists, academia, government bodies, general public. Baseline data are important but might not be available or complete, such as demographic data, sectoral data, land use, map, etc. Assessment can be carried out at the national level, sub-national level, provincial level, municipal level, even infrastructure level. It can focus on present conditions or can extend into the future to take into account environmental changes. As a result, both actual and potential hazard can be identified. These are some of the examples. So this is a flood hazard assessment maps that we did in Timor-Leste, and which is being used by the government now. This is the flood hazard and exposure map based on that. And while we put up our flood map and exposure, as well as overlay the hazard with the billing footprint, finally we see the damages. So this is simplistic overlaying of different layers of maps to come up with the risk assessment results. And now we have a query like what tools are needed and who can do that. Of course, the tools are mostly the hazard analysis tools, GIS tools, and others. Along with, we will need so many multidisciplinary team, including engineers, hydrologists, and socioeconomic analysts, and so on, to come up with all this hazard analysis, hazard vulnerability, and risk assessment. So on the exposure assessment, we need to do field survey to verify the present condition in field. This is one of the example I did in Timor-Leste in 2013, remember? So we have to go to sample pilot houses, pilot resources, and pilot built environment to get the information from the field to verify against our model and calibrate our model, vulnerability model, to run for that specific area. We need to also collect the existing damage information so that our vulnerability curves and damage information curves will be different or will be calibrated for that specific area itself. So this is one of the damage function sample example for flood. So while the water level goes up, the losses will be much more higher for different kind of buildings, like of course for zinc, clay, wood, bamboo, trunk, iron, or soil with the soil or tiles. The building will face more losses, while the concrete brick with concrete wall may face a lesser trouble due to the water depth. Of course, the building cost differs, so altogether overall damage will be different if we put it in terms of total cost. So this is one of the example using that curve, how we come up with these kind of flood risk assessment maps. Risk assessment for building inventory. So these are some of the functions that we developed, and also took this replacement cost from the country perspective to come up with overall loss in the GIS map. This is another one, flood risk map for housing sector for 100-year return period of flood. So this kind of thing will provide baseline for the decision makers, like what kind of decision they should take for different kind of infrastructure development in future. To summarize, disaster risk assessment utilizes a lot of data, scientific approaches, engineering principles, and GIS techniques. It requires specialists from various fields such as meteorology, hydrology, seismology, urban planning, civil, structural engineering, GIS, remote sensing, and statistics. It's the foundation for other risk reduction activities. Can be done at all geographical scale, regional, national, subnational, city, and community level. It's not a one-time study. It must be reviewed and revised in the future. So risk assessment outcomes are coming up like this. I'm just showing it again. And then these are not the end game of this just a risk assessment. These maps must be used, which we'll be talking in the next session.